The nearby planet group is turning and acting as a power. The world is turning and following up on it, pushing in. So, on the off chance that you decouple from them, then you have no force pushing you through, and you can basically make a trip quickly to any place in the event that you have the right frequency. Everything revolves around frequency. If your past hasn't occurred and your future doesn't exist, we have all been deceived. Time is maybe the greatest magic trick that we all aimlessly trusted in. So it wouldn't show an apparent method for impetus, just like these UAPs, unidentified aerial phenomena, don't show an apparent method for impetus. They don't have an intensity signature. No, so they must be working on something else that is permitting them to push, and then you could sort out some way to control that. Take the frequency of the Earth and find out everything that's the same and inverse. Say to him that this is the very premise that new disclosures made by the James Webb Telescope are pushing forward. You'll be stunned to know that the greatest name in mainstream science is affirming what we have thought for quite a long time doesn't exist. Join us as we investigate why Turan Howard believes that the James Webb Telescope has discredited us. Time is a disputable look at the closest clock. What you're looking at is one of the most dubious, most questioned, and most complicated ideas of physics, time. In the investigation of space and matter, time is by far the most difficult subject in science. It feels, however genuine as it might be, conceptual for us. Time resembles a stream. It flows, it moves unavoidably forward. Time also has a course. It always moves forward unless and until you have coincidentally found a time machine. It also has an order. One event occurs after another. You can't skip one event for another, and of course time sets have a term too. It is a quantifiable period between events. Your second is your present, which is real as space puts it. Time is by all accounts the universal foundation through which all events proceed, with the end goal that order can be sequenced and lengths measured. Yet, imagine a scenario where we tell you that all that we have described isn't real and it is simply in your head, or maybe it involves etymology. Anything future or past lets us know that time isn't consistently feasible. What we have is the advantaged present. For quite a long time, scientists have been inquiring as to whether time represents the reality of the physical world or if it is a mere artificial construct that we have accepted to make sense of our existence. Within this argument, you'll see that time is a social construct too. We believe that the devastating great conflicts from the 1900s are finished and cleaned for, since they are a matter of the past. However, scientists speculate that time may not work with the levels of progression and irregularity that we have expected to be the downright presence of time or its smooth continuity without parts. The occurrence as we know it today may be non-existent. Yet, we also can't deny that the passage of time is the most essential element of human experience. Take any emotion or moment. Everything is bound to slip into the moment of time. This is maybe the most personal experience we have with space or mass. When time falls through our fingers to start some kind of change of events, it seems like a journey of an arrow that takes you from the direction of the past to the future. For some scientists, it is tantamount to a constantly moving stream bearing our present but taking us to some kind of perspective or spatial quantity. Let's assume that time slips past when an individual is grieving. You experience loss, and over time, your loss feels less devastating than the moment it happened. We attribute this experience to the progression of time, implying that time, as a physical quantity, has adequately passed to give you space to deal with the loss. However, here's the thing. There may be no scientific reason for the progression of time at all. Stunned at this point, the centrality of time, no matter how many analogies we use to describe the progression of time, there's something disturbing about it as well. You don't see anything in known physics that can explain the reality of the passage of time. Up until now, even after spending many years on the scientific concept of time, we haven't found any scientific evidence that there is a substantial reason for the entry of time or its flow from the past to the future. If anything, physics tells us the exact opposite. According to physicists, time doesn't flow or can't flow because it isn't really real. All that you see on your clock or the way you conceptualize your life in a sequence of events has no scientific confirmation. It's all a major misconception. This is an idea that many scientists and scholars have been exploring for years. Even big names like Turan Howard have commented on this controversial idea. But then, can anyone explain why we hardly wrestle with these hard-hitting questions? How is it that we have deluded ourselves into believing that our present is unique when scientists say everything is happening all at once? To be fair, the study of time is intuitive in a moment. If that moment is real, everything changes for you. Turns out, there is no such thing as past and future, at least not as scientific measurements. We have consistently heard that time is fluid, and that is because big names in the scientific community continue to reinforce that idea. What's truly happening involves scientific inheritance. There is a clear split and an excellent debate. One group of science sees time as we understand it, or if they don't fully buy into the idea, they are merely maintaining appearances. Then there are scientists like Howard who believe time isn't fluid in the way we grasp it. It barely exists for groups who also believe in this. NASA is maybe the quintessential name, thanks to the authority of the James Webb Telescope, an instrument so powerful that it can look into the history or the past of our universe when it was in an infant stage. But if time is going on all at once, what is the telescope looking into? That is the topic of great importance that has stunned mainstream scientists. Turns out, time isn't of the essence by any means in our standard life. We divide time into three distinct parts: the past, our present, and the future. This is how we etymologically understand our lives as well. The actual structure of our language revolves around this central distinction. Our existence is our present. The past is the actual slip of time we just talked about, and the future is, well, what will come. We don't know all the details about this understanding. Logical Americans say, in this basic picture, the now of our conscious awareness floats consistently forward, changing events that were once in the formless future into the concrete present and then consigning them to the fixed past. Well, even outside the scientific concept, this is simply common sense to us. However, it still remains in scientific contradiction with modern physics. Even Albert Einstein called the past, present, and future stubborn illusions. This is where the special theory of relativity takes root. According to the famous physicist, time is relative. In very simple terms, the rate at which time passes depends on your frame of reference. Two people in two different frames would experience time differently. For example, they may not agree on how long an event took place or its duration. The very measurement of a second can vary. One observer's second can be longer or shorter than another observer's second, depending on their frame. So, even our synchronization is relative. If Einstein's words are anything to go by, there's no significance to the present moment since, well, why is NASA so determined to demonstrate the concept of time? When the James Webb Telescope finally became functional, the space organization had promised a lot. It seemed like the telescope was designed to give us a glimpse into the universe when it was only a child. Indeed, the telescope has surpassed everybody's expectations so far. The very distant images of galaxies and celestial developments from around 13 billion years ago are striking enough to make anyone question the origin of our universe and the timing of its appearance. And here's where all that changes thanks to this technology. The data we are getting is both stunning and nerve-wracking. If we follow Einstein's theory and believe that all that we see is happening all at once, how is the telescope getting data about the past? If our past doesn't exist, it really means that there is no actual distance between us and these systems. And if there's no distance and we are seeing everything simultaneously, the telescope will either be looking into the past that we have actually lived, so why are we getting this data? How does this make sense? It is astonishing. On one hand, scientists have accepted that time is a construct, and on the other hand, this technology has allowed us to actually see some tangible data about the past. If the time we know is an illusion and this distance has nothing to do with time, how is the telescope getting data? The farthest galaxy that the telescope has detected is 13.5 billion years old. It has identified around 12 billion years old very large black holes and 11 billion years old mergers of galaxies. However, what's even more fascinating is the image of Andromeda that the telescope has captured. In an astonishing revelation, the image is of a star that lies around 28 billion light-years from us. However, the telescope can see it because of gravitational lensing. A massive object between the star and the telescope bends the light and makes it visible to the telescope, making it the most distant star we've ever seen. These images tracing back to the earliest time of the universe are baffling for scientists too. While scientists have long contended with the concept of time, the telescope has somehow managed to grasp it. NASA still isn't backing down from the idea that time is crucial. The basis of this contention is the theory of the universe's origin, which discusses the earliest explosion after which the universe began to expand and form galaxies. The concept of time has long fascinated and bewildered humanity, from ancient philosophers to modern physicists. It serves as a fundamental framework for understanding our existence and the universe around us. Yet, as our scientific understanding evolves, questions about the nature of time become increasingly complex and provocative. One captivating perspective comes from theories in quantum mechanics, where time is considered differently than in classical physics. In quantum theory, time is often viewed as a parameter rather than a fundamental aspect. Events are described probabilistically, and the concept of now can blur into a superposition of potential outcomes. This challenges our intuitive sense of time as a linear progression from past to future. Additionally, the concept of time's arrow, which suggests an irreversible flow from order to disorder, entropy, faces scrutiny in quantum contexts. Quantum processes often exhibit time reversal symmetry, suggesting that fundamental physical laws might not inherently distinguish between past and future. This contrasts sharply with our everyday experience, where the passage of time appears rigid and uneven. In cosmology, the study of the universe's beginnings and evolution, time seems to play an even grander role. The theory of how things came to be posits a beginning to our universe marked by a blast of spacetime itself. However, theories like loop quantum gravity or eternal inflation propose scenarios where time extends vastly, possibly with multiple universes or cyclic patterns of creation and destruction. The idea of a universe where past, present, and future coexist as a fixed entity challenges our conventional understanding of temporal flow. This model suggests that all events,